Hello and welcome to our video on independent voltage sources. Today, we will explore the ideal voltage source and the practical voltage source, highlighting their important characteristics. Let's begin. Ideal voltage source. An ideal voltage source is a theoretical concept commonly used in circuit analysis to simplify calculations and understand basic principles. It is considered ideal because it provides a constant voltage, V, across its terminals, regardless of the current flowing through it. Additionally, an ideal voltage source has zero internal resistance, Rs. In the characteristics graph of an ideal voltage source, we plot the current, I, along the x-axis and the terminal voltage, Vt, along the y-axis. Since the internal resistance is zero, the terminal voltage remains constant regardless of the current flowing through the source. This means that no matter how much current is drawn from the ideal voltage source, the voltage across its terminals remains exactly the same. Visually, the characteristics graph of an ideal voltage source appears as a perfectly vertical line. This line indicates that the terminal voltage, Vt, is constant and unaffected by the current, I. It implies that the ideal voltage source can provide an infinite amount of current while maintaining a steady voltage across its terminals. Practical voltage source. In real-world applications, voltage sources often exhibit some level of internal resistance, Rs, due to various factors such as the construction of the source and the nature of the materials used. Therefore, we consider a practical voltage source that includes the internal resistance. When plotting the characteristics of a practical voltage source, we again use the current, I, along the x-axis and the terminal voltage, Vt, along the y-axis. However, this time, we observe a different behavior compared to the ideal voltage source. As the current flowing through the practical voltage source increases, there is a voltage drop across its internal resistance, Rs. This voltage drop is a result of the resistance dissipating some of the energy as heat. Consequently, the terminal voltage, Vt, decreases slightly as the current increases. The relationship between the current and terminal voltage in a practical voltage source is represented by a sloping line on the characteristics graph. The slope of this line indicates the internal resistance, Rs, of the practical voltage source. A steeper slope corresponds to a higher internal resistance, meaning that the terminal voltage drops more significantly as the current increases. It's important to note that even though the terminal voltage decreases with increasing current in a practical voltage source, it still remains relatively stable within a certain range. The decrease is typically small and depends on the internal resistance of the source. By considering the internal resistance, the characteristics graph of a practical voltage source provides a more realistic representation of its behavior in real-world circuits. And that concludes our exploration of the ideal and practical voltage sources. We've learned that while an ideal voltage source is a theoretical concept with zero internal resistance and a constant terminal voltage, practical voltage sources have internal resistance that causes a slight decrease in the terminal voltage as the current increases. Understanding the characteristics of these voltage sources is crucial in circuit analysis and design, as it allows us to account for the real-world behavior of electrical components and systems. We hope this video has provided you with a clear understanding of the ideal and practical voltage sources and their respective characteristics. Remember to consider these factors when designing and analyzing circuits to ensure accurate and reliable results. Thank you for watching, and stay tuned for more educational videos on electrical engineering concepts.